I hope all of you are doing very well. My name is Alima, and I welcome you to this masterclass on role of GIS in power distribution. This masterclass is a 2-day long masterclass, and it has been launched by Tata Power Delhi Distribution Limited. Before we move on, I would like to go through general instructions for this masterclass. This is a 2-hour long masterclass today as well as tomorrow. The faculty will conduct this session till around 4:30 p.m. and thereafter we can have a Q&A round. All the participants are requested to log into the webinar by their full names to optimize the bandwidth and avoid interruptions for now. Audio and video of all participants have been muted. Any query regarding audio or visibility of slides can be raised in the chat box. And please ensure good internet connection at your end. All questions for the faculty regarding the topic of the webinar should be asked in Q&A round. In and out time of all participants will be monitored for the attendance as well as the certificates. And if feasible, we will unmute the participants to ask the questions from the faculty at the end of the session. Till then, you can write your questions in the Q&A box or the chat box, and we shall address those questions by the end of the session. So we have with us our esteemed faculty, Ms. Sonam Malik. Currently, he's in Geographic Information System, that is GIS department. His total work experience is more than 5 years in the company. His past roles include she is a subject matter expert of GIS, which is system and database. And she has a deep knowledge in asset and network digitization and consumer mapping with GIS system. She played lead role for EHV network integration for GIS-based ADMS testing, data modeling, and patch management. And she provides data management, detailed mapping, and data analysis. She is also responsible for enhancement of existing GIS applications, new requirements, and its effective implementation, testing, and rollout. And she has a wide knowledge of use of GIS technology and equipment to produce detailed thematic maps. So I welcome you, ma'am. Before we move on, I would like to share the best practices of the company via corporate movie.
Think of a future, clean and shiny. A future of efficient and clean power, where efficient distribution systems and renewable power sources will ensure a smooth and secure supply of power. A future that is about to become a reality tomorrow. Creating the smart power network for the future. Welcome to Tata Power DDL. Jointly owned by Tata Power and the Government of Delhi, Tata Power DDL has re-engineered the power distribution scenario in North Delhi, its area of operations. Driven by the Tata Group's 150-year legacy of service to the nation, it is today providing cost-effective and reliable electricity to more than 7 million satisfied consumers. Since inception, Tata Power DDL's efforts at enhancing efficiencies and streamlining operations have improved performance manyfold. It has been continuously overachieving its targets of reducing AT&C losses, which stand below 8.4% currently. Tata Power DDL has drastically improved the response time and enhanced the quality and efficiency of electricity distribution with the implementation of smart grid technology. It is harnessing best of the tech innovations such as IT and OT integration, ADMS, Geographical Information System, and SCADA for remote and active monitoring of operations and fault conditions of the electricity on a real-time basis. The company is also taking significant steps towards implementing technologies for energy storage and microgrids for sustainable power distribution. Its state-of-the-art Smart Grid Lab is the crucible on which the latest technology in power distribution and benchmarking are being developed. The lab demonstrates various technologies, products and solutions for power distribution utilities that are helping to improve connectivity, efficiency and reliability that is both scalable and sustainable. Tata Power DDL is steadfast in its quest to provide world-class services to its customers. The company has implemented a raft of technologies such as promotion of e-services for consumers via digital touchpoints, providing the best of metering technologies and automation of its field force. Existing and future consumer empowerment initiatives such as a mobile app, home automation and rooftop solar panels are not only ensuring customer delight but are also encouraging them to optimize their energy use.
टाटा पावर ने आज नया स्मार्ट मीटर इंस्टॉल किया है। इससे कंज्यूमर को पावर मिलती है हर डिवाइस के ऊपर जितना इलेक्ट्रिसिटी लोड है वो मॉनिटर करने की और इलेक्ट्रिसिटी सेव करने की।
One of Tata Power DDL's groundbreaking achievements is India's first rooftop carport solar plant at one of the Delhi malls. Tata Power DDL has also been actively promoting energy conservation through numerous projects and initiatives and other demand-side management schemes covering all segments of consumers. The company's commitment to these efforts have been recognized at various levels. Tata Power DDL is also unrolling a blueprint to help reduce pollution levels that include creating e-mobility infrastructure by setting up e-charging stations. Tata Power DDL has consistently aligned itself with various government-led schemes, both at central and state levels, to ensure maximum benefits for the overall development of the power distribution sector. And to provide the best of emerging technology to the people, Tata Power DDL has entered into numerous collaborations with key global utilities. It is already a significant contributor to India's improved position in the World Bank's Ease of Doing Business rankings, in which the ease of getting a new connection has jumped from 137 in 2014 to 24 in 2019. Tata Power DDL's excellence journey began with the adoption of the Tata Business Excellence Model in 2004. In 2006, Tata Power DDL became the first Tata Group company to cross the 500 band in its very first TBEM external assessment. It won the coveted JRD QV Award in 2014, and in 2017, Tata Power DDL was elevated to the League of Industry Leader band by scoring 656. Tata Power DDL has also won Tata InnoVista Award in the Promising Innovation category in core and support processes. The stellar work done by the company has also been recognized at various forums. As a part of the illustrious Tata Group, Tata Power DDL has adopted the group's ethos of giving back to the society. It has stepped beyond its core mission of providing seamless power supply and has embraced the task of empowering the underprivileged sections of the society. Inspired by the brand philosophy, with you non-stop, Tata Power DDL's Sathi is the umbrella brand under which a host of highly successful initiatives have been implemented. All the programs under Sathi have been classified into 4 verticals. Under Unnati, various programs are run, such as Women's Literacy Center, Entrepreneurship Development Program, and Vocational Training Centers. These are designed to help the women gain confidence and find their place in society. The Sanjeevani program focuses on better health and medical facilities for the residents of slum clusters. Under the Ujjwal scheme, deserving students of Delhi government schools of class 10th and 12th get scholarships and guidance for further studies. Club Energy is a program that aims at sensitizing school children about power conservation, the environment, and climate change. All of these together, with its value-based leadership, has made Tata Power DDL one of the best places to work. The company has been ranked as amongst the best companies to work for in India. And with the well-being of the workforce in mind, safety best practices are rigorously implemented. The workforce is also kept motivated through regular activities and events. Special emphasis is also laid on empowerment and better career opportunity of women employees. Over the years of its transformation journey, Tata Power DDL has acquired and developed its knowledge base built its core competencies in utility management and has used these competencies to transform the power distribution sector in different geographies, both nationally and internationally. Today, Tata Power DDL is a partner of choice for other distribution companies across the globe. The company is hand-holding several utilities of the developing nations in the African, Middle Eastern and Asian region. It is providing synergistic value to utilities undergoing reforms process and upgrade them to become smarter and future-ready utility through its specialized offerings. For all its partners and customers, Tata Power DDL aims to be the most trusted provider of reliable, competitive and sustainable power and services. Using the very latest in technology and innovative solutions, it is gearing up to provide smarter, more efficient power solutions in the future. A future where Tata Power DDL will not just be at the forefront of power distribution in the capital, but will be a key player in the upcoming smart cities across the globe. Tata Power DDL, with you non-stop.
So that was all about the journey of Tata Power DDL so far. Now, I request Ms. Sonam to please proceed. Over to you, ma'am.
Thank you, Alima. Good afternoon, everyone. And my introduction has already been shared with by Alima. Now I will start the presentation. Role of GIS in power distribution. What do we understand by GIS? GIS here stands for Geographic Information System. And we all use GIS in our day-to-day life, like while planning a trip to somewhere and while booking an Ola or Uber. Like Ola and Uber are also using GIS. GIS is geographic information along with attribute information. So it is a system where you get the locational information and about the attribute also. Third is food. When we order food, we easily get to know where the person has reached, what is the route, what is the distance. So this is all GIS. So geographic information here consists of description of the characteristics of geographic phenomena. Geographic information क्या होगी? Natural resources होंगे, man-made resources होंगे. और these characteristics include location, attributes, relationship with other phenomena, and how these characteristics change over time. So this is about GI, geographic information. Now, what is system? System is a computer-based system for collection, modeling, storage, integration, management, retrieval, display, and analysis of geographic information. जब हम geographic information को एक system में एक software में डालते हैं तो उसमें हम different analysis कर पाते हैं, storage कर पाते हैं, modeling, data modeling कर पाते हैं. So this all combines geographic information system. अब ज्योग्राफिक इंफॉर्मेशन सिस्टम को इलेक्ट्रिकल नेटवर्क में कैसे यूज करते हैं, किसी यूटिलिटी में कैसे यूज करते हैं. यूटिलिटी इन द सेंस कि आपकी जो बेसिक नीड्स हो गई, जो यूजफुल रिक्वायरमेंट है आपकी, जैसे इलेक्ट्रिसिटी है, गैस है, वाटर है, तो ये यूटिलिटीज जो है जीआईएस को इम्प्लीमेंट करते हैं. और वो कैसे काम आता है, दैट आई विल डिस्कस नाउ. तो हमारे यहाँ पे टाटा पावर में जो जीआईएस है, हमने उसमें ईएचवी नेटवर्क को पूरा डिजिटाइज किया हुआ है. ईएचवी नेटवर्क is 33 kV and above network. तो सारे ग्रिड्स हमारे मैप्ड हैं, ग्रिड के इंटरनल सारे मैप्ड हैं. उसके बाद एचटी नेटवर्क मैप है, दैट इज 11 kV केबल्स, कंडक्टर्स एंड सबस्टेशन अलोंग विद द कनेक्टिविटी. तो ईएचवी में जो ग्रिड है वो अगर 11 kV फीडर को ही जा रहा है नीचे तक, तो वो पूरा फ्लो सेम मेंटेन किया है, विच इज ट्रू टू द साइट. जैसे आपका साइट पे है वैसे ही आपको जीआईएस में फ्लो मिलेगा. तो दिस इज कॉल्ड टोपोलॉजी. या फिर बिजनेस टूल भी बोलते हैं हम जीआईएस में इसको। अगर बीच में कनेक्टिविटी कहीं पे ब्रेक है, दैट मीन्स वो सर्किट आपका कंप्लीट नहीं हो रहा है, आपको जीआईएस में भी उसको करेक्ट करना पड़ेगा, अदरवाइज आपका क्वालिटी चेक में वो पास नहीं कर पाओगे आप। नेक्स्ट है एलटी नेटवर्क भी जीआईएस में मैप्ड है, विच इज 440 वोल्टेज केबल कंडक्टर एंड पिलर्स, फीडर पिलर्स, पोल्स एंड कनेक्टिविटी। और उसके बाद कंज्यूमर्स भी, हमारा कंज्यूमर की लोकेशन अलोंग विद द कनेक्टिविटी सब मैप्ड है। तो ये कवरेज है प्रेजेंटेशन का आज का। जीआईएस सिस्टम विल डिस्कस GIS implementation, how we implemented GIS in Tata Power DDL, demo session on GIS platform, introduction to QGIS, which is an open source software, GIS quality enhancements project. सो इन टाटा पावर की जीआईएस में हमारे पास एक सॉफ्टवेयर है जीआईएस का, जो फर्स्ट में डिस्कस करूंगी, डेस्कटॉप जिसको हम बोलते हैं। इसमें इसके लाइसेंसेस जो है वो सिर्फ जीआईएस मेंबर के पास होते हैं, बिकॉज इसमें इंसर्ट, डिलीट, अपडेट सारे चेंजेस जो है हमारे इस वाले प्लेटफॉर्म पे होते हैं। इसी का सेकंड जो रेप्लिकेट है वो है वेब यूजर एप्लीकेशंस। जो डेटा डेस्कटॉप में अवेलेबल है, हमने अपडेट किया है जिसको, वो सारा यूजर्स के लिए अवेलेबल है सेकंड वाले प्लेटफॉर्म पे। यूजर उसमें एडिट नहीं कर सकते, डिलीट नहीं कर सकते, चेंज नहीं कर सकते कोई भी, और वो उनको इंफॉर्मेशन देखने के लिए उनके लिए अवेलेबल है। थर्ड है वेब रेडलाइनिंग। ये थर्ड वाला प्लेटफॉर्म क्या काम आता है, अगर जोन ने या प्रोजेक्ट ने, हमारे इंटरनल स्टेक होल्डर्स जो हैं, उन्होंने अगर साइट पे कोई काम किया है, कोई डीटी लगाया साइट पे, डीटी मींस डिस्ट्रीब्यूशन ट्रांसफॉर्मर, अगर कोई साइट पे लगा है, तो वो जीआईएस को कैसे नोटिफाई करेंगे। तो वो उनके लिए थर्ड प्लेटफॉर्म है, वो इस प्लेटफॉर्म पे जाएंगे और वहाँ पे एक डीटी जैसा साइन बनाएंगे, ड्राइंग करेंगे जैसे हम पेंट में करते हैं, और उसको रेड करके जीआईएस को शेयर कर देते हैं एक लिंक। तो हम फाइनली जब वो नोटिफिकेशन हमारे पास आएगा, तो हम उस लिंक को ओपन करके उसी लोकेशन पे हम एक फाइनल डिस्ट्रीब्यूशन ट्रांसफॉर्मर जो है वो डेस्कटॉप वर्जन में अपना अपडेट कर देंगे, और वो अपडेट होने के बाद फिर वेब एप्लीकेशन में चला जाएगा, जो सब यूजर को रिफ्लेक्ट करेगा। So how it all started, how GIS was implemented and how it started. सबसे पहले है सैटेलाइट पिक्चर। सैटेलाइट पिक्चर से हम लिंक करेंगे रिमोट सेंसिंग, इफ यू हैव हर्ड द टर्म। रिमोट सेंसिंग इज when there is an information about an object without touching the object itself. लाइक सैटेलाइट से जो पिक्चर्स लेते हैं, या फिर ड्रोन से पिक्चर्स लेते हैं, या फिर एयरप्लेन से पिक्चर्स जो कलेक्ट करते हैं अर्थ की, तो वो एक रास्टर फॉर्म में होती है। रास्टर मतलब एक इमेज होती है वो, और उस इमेज को बोलते हैं सैटेलाइट, रास्टर बोलते हैं उस इमेज को, जो पिक्सल से बनी हुई होती है, और उस इमेज में कोई इंफॉर्मेशन नहीं होती है एडिशनल। उस पर आप क्लिक करोगे, आपको पता नहीं लगेगा ये पॉन्ड है, आप देख सकते हो ये पॉन्ड है, ये रोड है, ये बिल्डिंग्स हैं, बट आप क्लिक करोगे तो इन्फॉर्मेशन नहीं मिलेगी। तो व्हाट डू वी रिक्वायर टू गेट द इंफॉर्मेशन, तो हमें उसको डिजिटाइज करना पड़ता है, रास्टर से उसको वेक्टर में करना पड़ता है। अब ये सेकंड वाली जो इमेज है वो है डिजिटाइज्ड लैंड बेस। अब इसमें हमने पॉन्ड बनाए, रोड को डिजिटाइज किया, रोड को नेम भी दिया हमने, ये वाला नेम है रोड का। रेजिडेंशियल एरियाज को हमने डिजिटाइज किया। तो जो भी लैंड फीचर है, मैन मेड है या फिर नेचुरल रिसोर्सेज है, हमने उसको सबको डिजिटाइज किया, और फाइनली हमने एक वेक्टर लैंड बेस क्रिएट कर लिया जीआईएस सिस्टम। सिस्टम में मतलब सॉफ्टवेयर में हमने एक क्रिएट कर लिया। तो सैटेलाइट पिक्चर है, फर्स्ट है हाई रेजोल्यूशन सैटेलाइट पिक्चर। हम satellite picture, high resolution satellite pictures we procure for utility license area, and after that we conduct GPS surveys. GPS is ground global position system, which collects coordinates, and we also collect ground control points, which are coordinates of a specific area. And after that we georeference the image. Georeference means when a picture is taken, it doesn't know where this was taken, but when we assign coordinates to each and every corner of the image, it sets exactly on the surface where it was taken. And then digitization is performed, and then field survey are done, and quality assurance at every steps. So first we finalized the area extent, which is the Tata Power area extent, and for that area only we procured images from NRSA, that is National Remote Sensing Center, and other than images, we also collected the information regarding the area from other authorities like DVB, which was Delhi Vidyut Board. They had some information based on as-built drawing, like documentation, etc. And existing map, topo sheets. Topo sheets are prepared by Survey of India. Every a part of India has some topo sheet of it, and it can be procured through Survey of India. And later, ground control points and georeferencing was done for this satellite imagery, and symbology and designing of database was also done at later stage. So we have this software. Now we have the images, and these images are geo-referenced, and we also have ground control points, so that it sets it exactly on the area where it was taken, and we have topo sheets along with it, and ground verification was also done, and attribute other attribute collection was also done. Like we are digitizing a road, and we doesn't know what road is it, so we go for a survey and we collect the information about the road, whether it is road name, road type, highway, national highway, state highway. So along with the digitized layer, we also update the attribute information of it. So what is feature? A feature is a single entity in GIS that has both geometry and attribute data. So GIS is made from point, line, and polygon features. In point, we only have a node that can be shown with different designs, like we have circuit breaker and poles and consumers. So we show it through a point, and the point can be shown with different designs. Second is line. Line has two nodes, or it can have multiple nodes, and line can be shown through different colors, and we can also define its type and colors. Polygon. Polygon is an area like a building, a substation. So these are components of GIS. First is what we require to have a GIS, a system. The first is GIS software, then people, then processes should be strong, hardware devices. Hardware devices, we have computer, and here I'll also discuss the GPS, Global Positioning System. So what is a GPS? How does it work? We all know about the GPS. GPS is originally from US, United States, and its original name is Navstar, Navigation, Satellite, and Time and Ranging. But this also comes under the GNSS, that is Global Navigation Satellite System. GNSS is a term where we have multiple constellations of from different countries, like Navig. Navig is Indian constellation, but it also comes under GNSS. GLONASS is from Russia, Galileo is from Europe. So these global positioning system also tells about the location at any point of Earth. So we'll discuss this further in detail. First image is raster image, which I was also discussing earlier. And second is vector. We have raster image, it has pixels, and then we convert it into vector image. And vector is converted through features, that is point, line, and polygon. Like if we have a line in GIS, line means any trunk feeder, we click it on a trunk feeder, then we also get the attribute data of it. Attribute data includes GIS ID. GIS ID is a unique ID for every feature in GIS. And there is trunk feeder name, district code, and zone number, voltage rating. life cycle status. So along with the line, we also collect the attribute information of it, which we do not get in image data, which is raster data. So this is a land-based vector data in GIS, where we have buildings, roads, parks. Second is electrical network. Here we are having uh, consumer base connections, ST, lines, substations. Now these are interlaid. These both layers are interlaid now. Along with the features of residential area, land base, we have electrical network upon it now. And cloud map, which is Google Map or any open source map, can also be combined with this data. It can act as a backdrop of our layer. Like here, you can see Sri Jagannath Mandir. So this information we get from Google. GIS in Power Utility does not capture this data. So along with Google Map, we also get the additional information. Electrical network summary. So first we have DTL grid. DTL is Delhi Transco Limited. These are 220 and 220 kV above grids, and where we have supply in Tata Power grid station, that is 33 and 66 kV network. Then 11 kV network where substation DT is on DT is poles, 11 kV cables are covered. Then LT network along with poles, feeder, pillars, and consumer also. These all have been mapped in GIS with respect to latitude longitude coordinates, except the part of grid internal. Grid outer part we have maintained as latitude longitude, but internal part we have created as a single line diagram, and the connectivity is also kept as same as at site. Design workflow. How a design is created in GIS. When we have GIS system, that is desktop, and we get notified that a distribution transformer is um, augmented at any place, and we have a notification and network changes are required in this notification. So we create a design. We go to a scale, zoom scale, where DT is to be augmented or DT is to be placed. So we'll create a name like DT, new DT placement at zone number this. And we should also try that there is no overlapping of designs. Like there are many persons in GIS group. So somebody might be working on 414 zone DT number one, and another person should not be working on the same DT. The area should not be similar so that conflicts can be avoided at later stage. So while designing, we insert, delete, or update changes in GIS, and then it gets to the quality checks. Quality routine checks are defined in GIS system, and then network connectivity tools, which is circuit build, is also done. Like you can see that there is some snapping issue. The line are not connected properly, so it will not pass through the quality check of circuit build. It will get an error, and you need to correct it again and place the node to other line. Like snapping should be proper in this case, and then it will pass through the quality check, and finally the stages data updates. Then it is posted and then finally completed to ADMS. ADMS here stands for Advanced Distribution Management System, where the GIS data is replicated. GIS data goes to the ADMS system, and it is visible as a single line diagram there. So finally, a design is completed to ADMS system, which is for operation purposes. So this is geographical boundary of Tata Bar DDL. We have 12 districts in this. So without GIS, you get the tabular information in Excel. But to have a visual effect, you need GIS. Like you can easily identify the areas, and further you can have the zones. Each district is divided into some zones and then localities. GIS for end users. Like I was discussing the web application. So left hand side, we are talking about the web application. There is search asset tool. There are different tools which users are using, and the trace tool. Further, I'll give a demo to this application. And second part is system and process integration. Like other groups are also using GIS. So these are like ADMS, Advanced Distribution Management System, energy audit for energy capturing. Like there are some consumers connected to a DT. So energy audit group will get the report of consumers, and it will calculate the energy, and it can compare the energy with DT energy. So they analyzes the energy inputs. Connection management. Before giving a connection, new connection to any consumer, first report of GIS is asked, so that they can check the feasibility if there are poles, or if there are multiple feeders, if there is any connection which is feasible to the pole. So they ask for the GIS report. Next is network planning. Before planning any changes at site, network planning group uses the GIS data and plan if there is any requirement of grid, like a new grid. And they also check the GIS data if there is any space, if there is any feasibility. So they plan accordingly as per GIS data. Asset management, we capture all the asset information, like its life cycle status, when it was commissioned. So this all can get from GIS. And there is website, that is web application. So this is the web application platform which is open for users. There are some assisted searches, like if we click on a power transformer, it will give the information of what type of transformer it is, what is sub device type, what is life cycle status, DT number, which is also unique, what is its usage, distribution or transmission, name of the transformer. And on the right hand side, you can also see the specification of the transformer and also related records. Next is consumer information is also available on this platform. Like if we enter a registered number here in the search, we'll get the connection detail, the building detail where this connection is established, and we can also see the connectivity. Where this consumer is connected from. Like we can also go till grid level. Like first we'll go to pole, and then we'll also trace till DT, and DT to transformer, power transformer. Next is we can this we have trace function. We select a consumer, and then we trace it till HV network upstream. So it will go towards the grid level side, that is 3366 kV. So through which we can get the connectivity. Next is QGIS. Q stands for Quantum GIS. That is an open software for everyone can use it. So here in Tata Power also, we use QGIS for some thematic map and other information. So there is menu bar, toolbar. You can easily download, install it from Google if somebody want to explore. So there are different layers we can add to QGIS, like vector layer, raster layer, delimited text layer, Excel. So there are different um, data formats which it supports. Like here we are taking this district shape file. I've downloaded the shape file in this add layer, and then select attribute table, and then we also get the information about the attribute along with the shapefile location. We can also change the styling by going to the properties and then change the symbology, and we can categorize it to different color as per your choice. And now you can see the difference. We can also change the labeling, means code. You can also give the code, like district codes are already there, and you can also show it to map. You can change the transparency, opacity. So there are different tools you can explore and see the changes. And you can create thematic layers of different types. There are other geoprocessing tools in QGIS, like Clip tool. Here we only want a zones information. We don't want the entire 12 districts, and we only want the information about the one district. So we'll by using the Clip tool, we get the in step 3 you get the one district information. And this data along with other Excel data, like if we have um, how many power transformers are there in a district. So along with the shapefile of district data, we can also merge the Excel of which contains the numbers of power transformer, and we can also clip the layer along with the power transformer for one district. Another is buffer, where you can buffer the area according to your usage, like 5 kilometer. Like you are residing in Shalimar Bagh, and you want to see which restaurants are coming in 5 kilometers. So you will create a buffer, and you will also add the restaurants layer. So you will get the information about the 5 kilometer buffer area. Now we are coming to TAPO1. TAPO1 stands for Tata Power Positional Accuracy Network. So this is a quality project which adds the which improve the quality of GIS. So first we'll explain the positional accuracy. How a GPS work. Suppose I want to go somewhere, and I will now I will turn on my GPS, and it will our phone works as a receiver, and it starts receiving the signals from the satellites. Like GPS is originally from US, and it has constellation of around 24 satellite orbiting around the earth, and every satellite is covering some part of the earth. And at whatever point you are, at least you get 3 to 4 satellite coverage every time at any point, and through which the signals are received by this receiver. And like a satellite covers some area, B satellite, then C satellite, then the overlapping part is trilateration. That is where you are. The smaller the area of trilateration, the better you get the accuracy. So there are some errors in through phone while we check the location. And it doesn't matter if we want to reach somewhere. Like if somebody want to reach to like Punjab sweets, and you turn on the receiver and you get the accuracy of 5 meters, but it doesn't matter if you are going to a place like 5 meter, you will get to see that it is the Punjab seat is also in front of your eyes. But if you want the information about an asset, like where is the power transformer, and you get the accuracy of 5 meters, but it doesn't work like that. You need to be precise about the asset. So here DGNSS stands for Differential Global Navigation Satellite, where we reduce the error, and it comes down till centimeter level. And here you turn on the receiver. Here you can see that a receiver is changed to a rover. We call it a rover and receiver. And there is a base station on right hand side, which is placed at a certain point, and it also gets the signal from same satellites, as the receiver gets the same satellite, and it will calculate the position on real time and sends the signals to receiver on real time basis. And in this way you get the accuracy of 2 centimeter level. So, considering the technical limitations of general GPS-enabled device, high accuracy device ecosystem that can capture centimeter level accuracy is proposed to be adopted for GIS data notification and update. When a person works on a site, it uh, creates a notification, and it creates a red lining, which I was talking about, and that it will mark the area that here I laid my cable, but it is also only on the basis of best estimation and reference. It is not on the basis of geo coordinates. So we require such type of device where we get the better accuracy. In case of underground cables, like we have a base station, then rover. Rover is the receiver to which we move to take readings at different places of site. So a surveyor will carry this rover, and it will calculate the coordinates on real time basis. Base will send the corrected signals to rover. This is controller like a phone device only, which will be connected to rover. And there is survey mobile app through which we collect the coordinates. So here base station is already set up on in Rohini, and it if we work if it works on radio frequency, it will cover the 5 kilometer area. But if we work on GSM SIM based, it will cover the entire area. That means if a rover is in Narela or Bhavana extreme ends, it will send this signal strength and quality will be the same, and it will give the accuracy of centimeter level only. And one fixed base station can serve multiple rovers. Thank you.
Thank you very much, ma'am, for sharing all the insights with our participants. I'm sure the session has been very insightful and helpful for everyone. So I request everyone to please write your questions in the chat box, and we shall address those queries.
Alima,
So,
can you
ma'am, we
read
have
the question one by one so that I can answer?
sure we have a few queries in the chat box if you see.
So Dheeraj Pandey has asked, how does trilateration increase the accuracy? Triliteration doesn't increase the accuracy. Triliteration is a method where three to four satellites cover an area, and which an overlap area is triliteration. Means the point where it is the point where one person is standing, where the receiver is on, and to decrease the trilation, we need accuracy. The shorter the trilation part, there will be the better accuracy. So we need to decrease the triliteration area. Dheeraj, you want to ask anything else? Hope I'm clear.
Yes, ma'am, he has written okay as a response, so we can move on to the next question.
Mahesh Gupta is writing, is this part of smart grid implementation? GIS is altogether a different system, and it is a technology where which is adopted by different utilities and different companies. So, smart grid implementation is a different thing. It can smart grid implementation can use GIS data, but these two are different. How to showcase substation internals? Substation internals are already there in GIS, which are shown as single line diagrams. And here we have proper connectivity, like first we have 66 kV power transformer, then we have 11 kV bus and 11 kV panels. So we show it as a single line diagram, which are already mapped in GIS. Can you explain SCADA OMS DMS overview? Okay, now in Tata Power there is ADMS, SCADA, OMS, DMS. Three platforms have become one. So, and this ADMS platform uses GIS data. GIS data is exactly replicated to the ADMS platform, and in ADMS platform it is shown as a single line diagram, and these does not have geo coordinates. Geo coordinates are maintained in GIS, and in ADMS, single line diagram view is given. So we have ADMS now. SCADA, OMS, and DMS are not there in Tata Power now. All three platform have merged into one. How the GIS data get integrated with ADMS. So when GIS data is one time was migrated to ADMS. Now when there is a new change, like there is a notification of power transformer, a new power or a new grid is coming to GIS. We will create this grid, and we will create a design. Then this design goes to ADMS. There is a SIM model, which is common interface model, which works as a integration platform in GIS and ADMS. So these every design is pushed to ADMS, and ADMS then post it and then complete it, and then the design is gets reflected in ADMS as well. Is there any company who can provide land base? What is accuracy level required for land base for power distribution network? Every GIS creates its land base. Like Google has created its own land base. Some companies where GIS is on implementation stage, they get the land base data from Google. They purchase it from Google, and land base is created on and over the satellite images, which is raster to vector. So according to the needs and requirement, land base is created. Like here we have land base of we have covered residential area, roads, parks, and trees are also in some cases. What is accuracy level of for land base? Uh, when a land base is created, like we convert raster to vector image, then we need to georeference the image. Georeference means we need to assign the coordinates to the land base. So it will set accordingly. It will get the virtual replica of Earth. So accuracy level comes when we have to map the assets, like part where is power transformer, where is grid. In that case, we need to go for surveys, and we need to collect ground control points. So accuracy level depends upon the asset to asset. In QGIS, can we change the format of database? Yes, you can change the format. Like if you have a CSV file, then you can convert it to shapefile, easily convert it to shapefile. Can you explain the DGNSS again? Okay. Uh, First, we'll understand what is GNSS, Global Navigation Satellite System. GNSS is a broader term where every country's constellation is covered, like GPS, GLONASS, and NAVIC. All these come under GNSS. When we add differential means we work on accuracy now. We have ground stations at Earth, which are continuously calculating the accuracy, and computations are applied. Then real time basis, the corrections are applied. When we get the better accuracy, we term it as DGNSS, differential GNSS. Yes. How to integrate meter data management? Like in Tata Power, now we are going towards the smart metering, and further we'll also start capturing some of the metering data in GIS as well. Till now, we don't have any such meter data available in GIS. Can you explain digitization? Digitization is like painting. When you open Paint, you open an image in Paint, uh, and you start single line diagram, like you create a line. When there is road, you create a line, and then you mention it that it is a road, and you also add the other information. When there is a pole, you just click a node, and you create a pole, and you give the additional information to it. So digitization is a combination of point, line, and polygon data. Where can we get shapefiles to try in QGIS? There are many platforms of getting the free shapefiles. One of these are Bhukosh. You can try it on Bhukosh. You will get different kinds of shapefile, and you can explore in QGIS. In Tata Power TPDDL, GIS data directly integrated in ADMS, or it route through. It is directly integrated in ADMS through SIM, that is Common Interface Model. Why QGIS required? QGIS platform is user friendly, and you can there are different tools of which I have already explained. Clip, buffer, intersection. There are other tools also. So it is an open software, and thematic layers are easily prepared in QGIS. There are heat maps also you can prepare. Alima, can you check the last question?
Yes, ma'am. The question, which is how I can get privilege. Okay. We shall address the query to you later. If anyone has any other question related to the subject, then we will be happy to address it right now.
One has written how power theft is detected in LT lines. We have other groups also, which go on survey, and there are different platforms also to detect these LT lines. But in GIS, we does not have any tool or to where we can detect the LT lines theft. I think all the questions have been answered. What are main challenges GIS usage from operation teams frequently? Like so, I've explained the overlapping part. Somebody is working on a part of area, and another person is also gets notified on the same part of the area. So in that case, we get conflict in GIS. So the data can be late to integrate it with ADMS. So sometimes these challenges we get, and also the input from the site. The input should be is easily available in GIS, and every change should get reflected in GIS for GIS system to work efficiently. Thank you, everyone.
So, if we have any other question from the participants, we can still take the questions. So, you are requested to please put your question in the chat box.
Yeah, it's time. Anima, can I give a demo on GIS so that they can better understand?
Sure, ma'am. We
Because we
also have
have
other
time.
questions.
Miss, okay.
Is there any field groups and how they can use it?
Is there any field groups how they can use it? Upender, I couldn't understand your. Can you please elaborate how? What are you trying to ask? Are you talking about surveyors in GIS? Yes, Nena. This is about role of GIS. This session is about how GIS is helpful for field engineers. Upender, I'll give you a demo. I'm starting to give a demo. You will get a clear understanding on how user uh, use GIS. Alima, is my screen visible?
Yes, ma'am.
So this is the user platform WebGIS. Here we can search the consumer or any asset search, and in simple search we can simply go to electric substation and If you have any type of ID, notification number, you can enter here and you can directly go to the area. So while we zoom in to different, if a zone person has a list of consumers and he wants to check these consumers connectivity, he can simply write down the consumer number, and he can get the information on how, where it is connected, where the consumer is connected. So this is an 11 kV substation. This is RMU. This is how we show it in GIS. And this is circuit breaker, the symbology of circuit breaker. And this is how we show this transformer. So by clicking it, you get the information of device type, life cycle status, TT number, usage, name, substation name, consumer count, district code, voltage level, owner name. So these type of information are used by our internal users for planning purposes and for connectivity purposes if they want to check the connectivity, and for there are also different kind of reports um, they can get through this WebGIS. Now, if I show it a trace, so I have clicked on this transformer and then I'll trace it HV network type upstream. कुछ इशू आ रहा है इसमें ट्रेस में. There's some issue in trace. When we select this transformer and we if we trace it, it will go, it will show the connectivity till the HV level. Next is sketching tool. So this is for users. This tool is for users. They will click draw sketch and they will create a line. Like if they are laying a feeder there, and they will simply create this line and they'll submit. Like they can also one DT, one line. So by this tool, we get the notification from a different user group, and we final it in GIS desktop. They share the task ID, and then we check it in GIS, and then we update in GIS platform, and then it gets integrated to ADMS. So they will type the LT change. So this task ID is generated 22794, and the user will share the task ID with me, and I will check the changes, and then finally update in GIS. There are other reports also, like DT report, grid trunk feeder, till DT, power transformer reports, what all power transformers are and where these all are connected, street light report. And according to the users, we also create different thematic maps here. Like this is one kind of map where these VT centers are visible. These star marked are VT, all the vocational training centers, which comes under Tata Power area, and which are created for special consumer group. Next is SCB map, heat map. It is taking some time. So we have this list of vocational training centers, and we can reflect it on GIS. And later we created a heat map on this by creating a buffer, and it will tell the which consumer base get the benefit of these VT centers, and where we can create another centers. So this also helps in planning purposes for other groups. These are SCB consumer base for which the VT centers are created. So this thematic map is for loss wise DT, and loss is calculated, and given the interval, we can reflect it with different colors, and we can also merge it with different data. There's another map of loss wise LT feeder. So these are different types of thematic maps which we create for users. If a user have coordinate of any asset or any area, he can directly search by latitude, giving the latitude longitude here. So this is the grid part, the grid outer part. This is substation 220 kV Bamana grid. So on right hand side, we get the information about this grid, which zone it is pertaining, which circuits are there. This is grid internal part. This is single line diagram. This is not with respect to latitude, longitude, but the outer part is contains coordinates. This is 220 kV grid. So this breaker is 220 kV breaker, and this subtype of this breaker will be transmission breaker, which will create a circuit ID, a unique circuit ID, and this will flow towards the down. And here we have this is isolator, then lightning arresters. So till here we have 220 kV, and then there is power transformer which will be converting the voltage level of 220 to either 33 kV or 66 kV. And then here the circuit ID will change, and now the 33 and 66 kV HV network will flow here. And there is this breaker again, which will further charge the bus, and there are further feeder. So there is another grid which is Narela subsidy. Voltage level is so from DTL grid we get supply in Narela subsidy, which is 66 kV grid, and here we have uh, LAs, lightning arresters, then isolating equipment. So there is circuit ID which was flowing through the DTL grid. It will flow till the section of 66 kV. Here it is isolator, then circuit breaker, then there is bus, and then this bus will get charged from either of the isolator. And further this circuit flows here, and this is also transmission breaker. There the circuit ID changes, and another circuit starts from there, and this transformer converts the 66 kV voltage to 11 kV, and then 11 kV circuit flows from here, and then this is 11 kV breaker, and then the bus is charged, and these are 11 kV feeders. This is cap bank. So initially we have defined the data modeling and how a particular asset should look in GIS. So these are all part of data modeling, how a breaker should look, how a cap bank should be created. So this platform is for users. We can on off the layer as per a requirement. And the other OpenStreetMap act as a backdrop to GIS data.
Thank you, ma'am. Now we have a few more questions in the chat box.
Which one is better, QGIS, is or Small World? In Tata Power DDL, we are using Small World General Electric Office, I believe every platform has some uh, advantages or disadvantages, we can say. Um, so comparison would not be the better way. How to work on GIS? So to start a system of GIS, first we need satellite images, which you can easily get on Bhukosh, and you can also get different type of shape files are also available. There are other platforms also which is given by Government of India. So you can download some images or some vector layers. Vector layers, I mean to say shape files, and you can explore it in QGIS. You can add layer in QGIS, and then you can combine it with other data if you get from Google, like uh, s- uh, another list of like restaurants or malls. You can combine this data with the shape files, and then you can create buffer. You can use the tool of clip intersections. There are other tools also. You can explore it in QGIS. How are underground cables are shown in GIS? Underground cables in GIS generally shown in as dashed lines, and according to the voltage level, like in EHV, we show dashed line with brown color, and in EHT, that is 11 kV, we show it in blue color, and then LT part of it, we show it in pink color. So these are line type feature, and we show it like that. And by using DGNSS device, we get the exact coordinate of underground cables. Our surveys goes to the side and then collect the coordinates of the cables in intervals, and then we finalize it in GIS and finally updated in GIS. How are streetlights shown in GIS? So streetlights are not directly shown in GIS, but they are streetlight poles. And in when we click on a pole, we get attribute if this pole contains streetlight. So we update as yes, and then we keep the streetlight as a part of attribute of pole. Streetlight complaints taken in ADMS. Yes, actually, streetlights are part of some are part of PWD, so some falls under that category. So those complaints doesn't come in ADMS. Please suggest some free GIS software rather than QGIS. Another is SW Maps. You can also explore SW Maps apart from QGIS. And other platforms are not freeware. You need to check that. Can you please suggest free GIS software? QGIS is very good software, and you can explore it. This is freeware. And can we get to know the faulty condition of particular transformer when fault occurs instantly by using GIS software? GIS GIS system gets the information from inputs from different stakeholders only. GIS doesn't isn't directly interlinked with real time location. So we don't get to know the fault condition of particular transformer. But in ADMS, when there is 66 kV and 33 kV power transformer, those are unmanned and directly controlled through ADMS. So there we can check the condition of device, I will say HV, high voltage assets. GIS data digitization in web application get directly posted in production server or need some QC before posting in production. Yes, GIS has some quality check tools through which a design goes through, and if it fails, you need to correct that part again, and then it will go to the production server, and finally it will be visible to ADMS and other users also on web application platform. May I check circuit length of HT feeder span length? Yes, yes, you can check the circuit length. When we get notified of a cable or a conductor, the zone provides the actual length. Actual length means which is laid on site. Like 100 meters conductor is used at site, and when we draw it in GIS, we get the length of around 85 or 90 meters. So we contain both the information, geometric length, which is updated in GIS, and the actual length, which is finally uh, laid at site. Are underground cables tracked by whoever is digging on roads? There is fault locating crew in Tata Power DDL, which can locate which has a GPR. They use GPR, that is radar, ground penetrating radar, and other such devices which can track the underground cable. And now we have in GIS the DGPS, that is DGNSS, and through which we get the exact coordinate of cable. And when we want to search for underground cable, we take the rover to the site, and we can exactly go to the same site again, and we can track it. It will be done. So it will be done in backend or in web. What are you talking about? About QC. Okay. These are part of backend system. Automatically QC are run, and you will get notified when there is an error, or if this pass through the QC. These are automatic in system. Can we measure sag between the four? On site, there is sag, there is loop, there is rising, but in GIS, we cannot reflect sag or loop or rising. In GIS, we have pole to pole measurement. So there will be difference in actual length and in GIS length. So we cannot measure sag between two pole in GIS. Zone or other user will give the data of how much sag is there on site. So we will consider that. Can you show transformer structure? This is transformer. This one. This is circuit breaker. This is transformer. This is how it looks in GIS. And by clicking it, we can check the attribute information of this transformer. Like nominal voltage, primary voltage is 11 kV, and it is converting it to 440 kV, 440 voltage. Can we show any fault in line through GIS? Like I said, GIS is not directly connected to the site assets, so we cannot show the fault in GIS. Fault information can be given by different groups to GIS. So whatever information is given to GIS, it is that only. If a fault information is given, we can update it in GIS, but directly it cannot show any fault in if there is any fault in at site. Our solar installation shown in GIS. We have started the solar consumer updation in GIS. So GIS is a combination of remote sensing, a system, hardware, people, process should be strong so that GIS can sustain, and GPS also, and remote sensing. So first term is remote sensing. Remote sensing means when a satellite captures images of Earth's part, and these images are stitched together, and then these images can be procured from different agencies, and we can digitize on these images and finally create a GIS database. And then after creating GIS database, we require GPS for better accuracies. And by using GPS, we assign the coordinates to these images to the vector layer which we have created, so that it gets stitched exactly as Earth. As we have features on Earth, so by using GPS, we can improve the accuracy of GIS. And this is the basic layer of GIS, that is land based and geoprocessing we call it, and then georeferencing we do. And after that, we can create our own layer. Like in power utility, we can create electric layers on it, grid internals, then substation, then other layers superimpose on land-based structure. And apart from this utility, in gas utility, they might be also maintaining the same layers as per their requirement. So this is how a GIS system gets implemented in any utility or any company. Any other question you want? Or any doubt in slide presentation? I can also show the exact GIS desktop, how it looks. I'm opening it. Are utilities sharing GIS data? When there is requirement, yes, sometimes we need to share the GIS data. Some other utilities working on underground work, and it wants to know that if any other utility is also clashing the same area, so it does not get the surprises in a subsurface area. It wants GIS data, so we sometimes provide the GIS data for the betterment of our utility and as well as their. I want to show the exact GIS platform, so it will take around 1 to 2 minutes. This is GIS desktop, GIS small world. So if you want to search for a substation, classes distribution substation are RMUs, and transmission distribution are EHV substations. So here we get the list of EHV substations. So these are all EHV substations, 220 kV, 66 kV, 33 kV. So if we go to Azadpur grid, this is the blue is the outer boundary of Azadpur grid, and here we can see the internal part of it. So these brown lines, brown cables are EHV cables. If we click on this, This is cable segment. There is this GIS ID, which is unique for every asset. 33 kV voltage type. And trunk feeder is Model Town grid to Azadpur grid. So this feeder is coming from Model Town grid, and this is Azadpur grid, circuit 1. This is a hyper node. This is small world application which we use in GIS at Tata Power DDL. This is network hyper node which connects the outer part of grid with internal part. It has two pin 1 and pin 2. Pin 2 is for outer part of this grid and pin 1 stands for internal part of it. So if we go to the internal part, so here is this hypernode. Through this tool, we can highlight the selected attribute, and this was connecting the internal part with the outer part of grid. This is a connector segment. Then there you can see there is a circuit ID ST22015444, which is coming from the model town grid to Azadpur grid. So this circuit ID will flow downwards in assets. Like this is grid isolator. This is how we show a grid isolator. Then you can see the circuit ID is same. These are CT, that is current transformer. This is circuit breaker. Then the circuit ID is the same. You can notice this is bus, 33 kV bus. Circuit ID is still the same. Now here circuit ID changes. Till here we have the same circuit ID till bus, and then we have a circuit breaker. Its device type is transmission breaker that will transmit another circuit, and it will change the ID. And this ID will flow downwards. And you can also see the nominal voltage level is 33 kV till here. And these are LA, lightning arresters. Segment installation has voltage level of 11 kV. This is 11 kV circuit breaker, that is incomer, and then there is bus. So this is how we maintain the internal grid assets, and then these are 11 kV feeders, and further this hyper node will take us to the outer part of grid. So this blue line is 11 kV feeder. Here we will try to trace it downstream. We go to electric trace. If we want to trace the connectivity of any feeder, any asset, we will add the segment and we will trace it downstream. Tracing is taking time. We can directly check where this feeder is going. Now it is selected. So this feeder is 11 kV feeder. There is GIS ID in service, underground. This cable is underground, company owned. This is going towards Azadpur grid to interconnector to Jahangirpuri grid. This is RMU. So if a user share a change on this grid, so it is shared as part of sketching tool. And when we want to final it in GIS, we will create a design file, new project, then we'll create a, like if the change pertains to HV, then we'll write HV Azadpur, and we can write notification number and then date. Now when the design is created, this is in editable mode now. This is new job, read only. So we'll take it to InDesign. Like if there is a new feeder, we will simply take this word tool and which can create a line. So like this, we can create a line and we can add the information here. GIS ID, this will create on its own. So we'll write zero here. Cable type, network, MB, usage, mains डाल देते हैं. In service, nominal voltage 11 kV, mounting, underground, owner type. So these star mark details are mandatory and other can be filled in if required. Then we'll give it a route. We'll we'll say that what we have created in this part, this will give a route to cable. Then we'll create. Actual length is also mandatory. 10 here. Maybe our number. So this is how this cable will be created in GIS. And we can add other information also, like trunk feeder, sub feeder, commission by, commission date can also be added. And there is, here we can check the circuit. If we proceed this design, this will not pass as there is no circuit. So it will need connectivity through hypernode with internal breaker. So this is how a design is created, and there are different PLTs, layout tools. Like this is transformer. Here we can create transformer, circuit breaker, fuse, pole, installations with assets, cut point, distribution transformer, bus bar, lightning arrestor. So all the asset information is given here. So we can select and create one in this part of area. So finally, if we are done with the work, then we'll save it and change state to pre-QC. So it will automatically start the QC tool. We can undo it. There are other such tool. Like if we want to split it, then we can split it by trail. The same way we can also merge two different lines. We can also change its area location also, like this. So this is how a digitization is performed in GIS. In QGIS also you may get the similar view, but you need open source data for that. And here is consumer mapping tool also. If we get notification about the consumer mapping, they will provide the installation numbers and pole numbers, and will start the consumer mapping by providing it an Excel sheet, and then it will automatically map the consumer with the given poles. So if by going through QC tools, if we get an error, then we'll go to manager, and the error will get reflected here, and we will check the description in this part, and will resolve the error. So these all brown lines are HV lines. Blue lines are HT lines, that is 11 kV lines, and pink lines are LT lines. This is how we distinguish the cables in GIS. These are poles, HT poles. This is how we show our consumer. This is service connection. This is a consumer. So suppose we get the information of mapping this consumer premise ID, that is also installation ID, with this pole, then the consumer mapping tool itself gets it mapped with this pole, and it will create a service line first. This is service line. Service line, and then service point. And with one service point, there can be multiple consumers connected in GIS.
So, ma'am, we have already reached our time limit and we have a few questions in the chat box.
Which application is this? This is Small World GE application, and this is based on licenses. We Tata Power DDL has purchased its licenses, and we are working on it. Is there any security mechanism in place to prevent any kind of attack which would manipulate the data transferred? First of all, this application rights are not given to other users also. And there is web application which is also in Tata Power DDL area, and you can't access the application from outside of Tata Power area network. So there are proper measures taken in that regard.
So I guess
Okay,
that's very
thank you so much. Thank you, Alima.
Thank you very much, ma'am, for joining us today and sharing all the insights with our participants. I'm sure the session was very fruitful for our participants. And thank you, participants, for joining us today. I will share the training material by the end of next session, that is tomorrow. So see you tomorrow, 3 to 5 p.m., and we'll discuss further regarding the role of GIS in power distribution. And we'll have another faculty to address you. So you may log out now. Thank you, everyone.